Welcome to Homework Lib.
In the given circuit, R1 having the value 8 ohm, R2 having the value 6 ohm, EMF of the battery is 48.0 volt and inductance to be 0.2 Henry. Internal resistance of the cell is negligible. At t is equal to 0, S is closed. In the part A, we have to find the current I1, I2 and I3. All these values we have to calculate. At t is equal to 0, just closing the switch, I1, I2 and I3 we have to find at t to be infinity. Find differential equation of I3 applying Kirchhoff's law. In D part, we have to find the value of time t at which I3 becomes half of I3 max. E part, we have to find I1 and I2 at I3 is equal to I3 max by 2. Let us start starting with part A. Just a moment, please. Part A. At t is equal to 0, when switch S just closed, the current in inductor is 0, that is I3 is to be 0. And I1 is equal to I2 according to Ohm's law. EMF upon R equivalent, that is 48 upon 80 plus 6, that is 3.43 ampere. B part, after the long time, inductor behaves as zero resistance path. So I2 will be 0 and I1 is equal to I3 is equal to EMF upon R1, that is 48 upon 8, that is 6 ampere. C part, potential, instantaneous potential across inductor will be L di3 upon dt. Now applying the Kirchhoff's law in the left part of the loop, in the left loop, we can write EMF minus I1 R1 minus I2 R2 is equal to 0, and in right loop we can write minus I2 R2 plus potential across inductor to be 0. So you can write minus I2 R2 minus plus L di3 upon dt to be 0. This is your second equation, and by junction rule I1 is equal to I2 plus I3. From equation 1, I2 can be written as EMF minus and putting in equation 2. So from equation 1 and 2 we can write I2 to be EMF minus I3 R1 over R1 plus R2. Now substituting in 3 we can write minus I2 R2 plus L di3 upon dt is equal to 0. Substituting the value of I2 from here, we can write E minus I3 R1 over R1 plus R2 plus L di3 upon dt is equal to 0. So from here we will get 1 upon I3 minus EMF upon R1 di3 is equal to minus R1 R2 over L into R1 plus R2 into dt. Integrating we will get ln of I3 minus E upon R1 upon EMF upon R1 is equal to R1 R2 into T upon L R1 plus R2. On solving this equation, I3 can be written as E upon R1 into 1 minus exponential of R1 into R2 into T upon L R1 plus R2 into T. So that is the answer of D part. Now in C part. Now in D part, T we find for I3 is equal to 3 ampere. So I3 is equal to 48 upon 8 into 1 minus exponential of 8 into 6 into t upon 0.2 into 8 plus 6. So t you will get 0.04 second. In E part, we have to find I2 and I1. I1 and I2 for I3 is equal to 3 ampere. From equation 4, I2 can be written as EMF minus I3 R1 over R1 plus R2. So you will get 48 minus 3 into 8 upon 8 plus 6, that is 1.71 ampere. Now by equation I1 is equal to I2 plus I3. I2 is 1.7 ampere plus 3 ampere, so you will get 4.71 ampere. That's all. Thanks for watching it.